Okay, let's talk about what standard deviation is. It helps us measure how dispersed the data is. Helps us measure how dispersed the data is. So we kind of talked about this a little bit yesterday because range also helps us decide this. If my class has an average, test average of 70, and most of them either got in like 60s, 70s, 80s, okay? Versus a class where their class average is 70, but some failed and some got 100, okay? Well, the class that got 60s, 70s, 80s is more consistent, and the class that failed and got 100, even though their average is 70, they're more dispersed. The standard deviation would be larger. Okay, the range would be larger. Okay, Randall wants to adopt a cat from the shelter. He's looking to adopt a Persian cat or a Burmese cat. I don't know my cats. He went online and searched 10 sites, and he wanted to know their average life expectancy. So here's the results. So on average, here's how long some cats lived. Okay, so we're going to enter the data. Okay, so give me a stat edit. I'm going to up clear down because I got stuff in there. Up clear down. Let's go L1 and let's put all that into L2. Okay, so here's what I'm going to do. I'm just on my home screen now. I quit out of the edit list. Okay, stat, calculate, one variable statistics, L1. Good? Enter. Okay, do we remember the X bar? That's the symbol for mean. So 14.3 is the average life expectancy. If you scroll down, you got your MED, so the median, the number right in the middle would be 14. You know what we're going to do for mode? I think we can just quickly look with our eyes here. Is there something that occurs the most? 14. There's 3 of them, isn't there? So I got 2 15s, so 14 beats it. I think, right? Oh, all of them. Yeah, I'm just looking at the Persians right now. Range. Do you want, we could sort or we can look with our eyes because there's not that many. What's the highest? 18 subtract 11. So the range is 7. Okay, and the standard deviation. So it is this little symbol. I'm going to write this down for you, which you probably want on your cheat sheet to understand the symbols.
What is that symbol? Is that like
it's like an O with a hook at the top.
Oh, okay.
I lost my cheat sheet.
Oh yeah, you don't want to lose your cheat sheet. Okay, can you repeat this except for when you do stat calculate one variable? You're going to be doing L2, right? Because that's where you put your data in.
Hold on.
So stat calc one variable statistics for L2. I got 14.6, and median, when I scrolled down, that was 15. Right here it says the max is 18 and the min is 10. So 18 minus 10 is the range of 8. What did you guys write for your mode? 16 appears 3 times. 15 appears 3 times. So guess what? You have 2 modes. Remember when we talked about mode? Sometimes you actually might not have any mode, and sometimes you could have more than one mode, and that's fine. It appears the most. 15 appears the most, and 16. And the standard deviation, so looking for that little symbol, should be 2.29, right? Okay, so let's talk about this. These numbers are pretty similar, right? The average life expectancy is pretty similar. But when I compare the standard deviations, this one is bigger, right? So here's kind of the difference. So the Persians and Burmese have the same average, but the Persians, let's say maybe if the average is 14, they might go from, let's say, 10 to 18 years. Versus the Burmese, if they have a bigger standard deviation, it's because some of the cats might have only lived 5 years and some like 20. Okay?
Are these all like natural death causes, or is this
Like hit by a car?
Yeah, like what if you get hit by a car? Then
This is like natural, like how naturally long most of them live. Okay, so forget the cat cuteness for a second, because obviously you know where my decision went. Which one would I want to buy and why? So you could argue if you buy a Persian, okay, it's a more consistent chance that it'll live around 14 years, right? But if you buy a Burmese cat, you're kind of taking more of a risk, because you could get a cat that doesn't live long or lives way longer, right? Because, right? Do you understand what I mean when I draw something like this? You could have a really young cat or a really old cat versus more Persians are into the middle of your data. Does that make sense to you? Okay. So again, analyzing these results, they both have the same mean. Looking at their standard deviations, this one's higher, this one's lower. So class A, their scores vary a little bit. And class B, their scores would vary a lot. It's how dispersed your data is. Your data is spread out more. So this class is more consistent. And this class, their scores are more spread out. Okay, so that's what standard deviation is telling us about the data. The data is going to disperse more. Okay, this might be a couple pages flipped, I'm not sure. Page 8. So data talks about a curve called the normal distribution curve. Okay. Actually, lots of times people grade according to a normal distribution curve instead of just your grade being 90, 80. Lots of times universities grade on a curve like this. Okay, so here's what happens. If you have a mean score of 71%, it goes in the middle. if your standard deviation is 4.5, that means if you score one standard deviation above the average, you got a 75.5. See what I did? I just added. If you scored one standard deviation below the average, that means you scored a 66.5. Now, this is a given number, which we will eventually put on our cheat sheet so you don't have to memorize it. 68% of your data will be within the 1 to 1 range, the negative 1 to 1. So this has a Z, I'm getting ahead of myself. Okay, we're going to talk about Z scores, so don't freak out, I'm telling you a Z score, but the middle is a Z score of 0. If you're one standard deviation above, you have a Z score of 1. If you're one below, you have a Z score of negative 1. Okay, can you get me those values? So go 71 plus 4.5 plus another 4.5. Okay, so the score of 80 is somebody who got 2 standard deviations above the average, 3 standard deviations above the average. So going this way is negative 2 standard deviations below and negative 3 standard deviations below. So like I said, lots of universities grade you according to this. So they take the average, and if you scored 3 standard deviations above the average, you get an A+. Okay, they kind of go according to that. And this happened to me once in university. It was a really hard test. The average was 38%. I got a 70% on this test, and I've never gotten a 70% in my life before, and I was like, this is horrible. I got an A+. Okay, because he's like, this was a bad test, 38 was the average, so he did this kind of thing. So if 38 was the average, I was considered 3 standard deviations above, so I got an A+, even though my grade was 70%. What's that? Okay, now, here's another number for you. So 68% of the data on the curve is located in that zone. Between here and here, so the second and the third, these extra lines are bothering me. So between the second standard deviation zone, underneath your curve is 95% of your scores. And then almost all of your data is going to be under the 3 to the 3 mark, the negative 3 to the 3, but it's 99.7% of your data. So there is a few people that are going to be on the outsides, which are somebody who's extremely, extremely high or somebody who's extremely, extremely low. There's a very limited amount of that, but there will be. Okay, grab your cheat sheet. We're going to put this on your cheat sheet. Okay, I need you to draw me a normal distribution bell curve. give me a mean, a +1 standard deviation, a +2 standard deviation, and a +3 standard deviation. A -1 standard, a -2, and a -3. Okay, then I went like that on top, and I said 68% is between the -1 and 1, 95 is between the -2 and 2, and 99.7 is between the -3 and 3. And then we're going to do some math, and we're going to figure out literally each individual section. Okay, so the title of this is normal distribution, when things are normally distributed. Okay, you ready? If this is 68%, what is in this side and this side separately?
34.
Did you do that one in your head? Without the calculator? Awesome. 34%. Okay, so this is 95. What do you want to do to get those spots? Divided by, well, you can't divide it by 4 because it's not like perfect rectangles. Do you know what I mean? It's not evenly, they're not 4 equal rectangles. Divide 95 by 2, so you can do that. Divide by 2. Okay, which means I need 47.5 on each half, right? Right? Does that make sense? 47.5 on each half. But if this is 34, what am I going to do? I'm going to subtract. So 13.5. Do you see, when you asked me about that before with the dividing by 4, do you see how the proportions are getting smaller in each rectangle? Because it's not even really a rectangle, right? It's a curve. So as you go down, the area in each is getting smaller. Okay, now can we do the same thing? 99.7 needs to be in here. Okay, so figure out what you want to do to get this next little section. You might have a different way. I know a couple ways I could do it. See if you can figure out a way to do that. Did you come up with a method? Anybody have an answer they're like so confident in? It's a small number. 2.35? You confident? Are you sure?
I think so.
Are you going to lock in your answer?
I will lock in an answer right now.
That's good. It's right. Okay. Then the little tiny little tails, I'm going to call them tails. There's a little bit left. There are a few people that get to be in that extreme zone, either extremely good or extremely bad. Okay, how much do I need on this half altogether? What should the whole half add up to be? 50. So what do you already got? So I'm going to go 50 minus 34 minus 13.5 minus 2.35. I got 0.15%. A very, like, right? It's really rare to be outside. That's somebody who's extreme. Like if I was measuring IQs, somebody who's extremely intelligent. Okay. Boom, everyone's good. Got this on your cheat sheet. However you want to arrange your numbers or whatever. Okay, so that's where they all come from. Okay, ready? Let's apply it. You have a mean of 80. I'm a drawer. You don't have to, but I'm a drawer here. You have a mean of 80, and your standard deviation is 3. So 83, 86, 89. You see what I'm doing? I'm adding 3. I'm going above 3 and then above 3 more. Okay, now we also have to go down 1, down 2, down 3. So minus 3 is, did you get 77? 74 and 71. Okay, question 1. What percent of the data is between 77 and 83? So I think you should all have your cheat sheet sat beside you, right? So I'm looking from in the ones, -1 to 1, which is the number 68. 68% of, okay, I'm going to say this is a test grade. 68% of the students got between 77 and 83% on my test. Okay, what percent of the data is between 74 and 80? Okay, so which number did we find on our cheat sheet? We're going to be going from the -2 line to the 0 line. So what value would that be? That would be all of this. I also wrote this down together. 47.5% of my students got between 74 and 80%. Okay, percent between 74 and 86. Okay, this is a larger span. I went 2 lines down and 2 lines above, right? Anybody remember that number? From the -2 to the 2 is 95% of the students scored in that zone. Okay? This is telling me how dispersed my scores are. Okay, we went from a 71 to an 83. So how much of the people scored in that region? So what are we going to do? Okay, so you need all of this region plus that one, right? So you need to make all those numbers together. I'm getting 83.85% of the students scored anywhere between those on the test.